Hi students, welcome to Preliminary Chemistry and the water topic. This is video number 11 and now we're moving into precipitates. So first of all, what are precipitates? Well, precipitates are substances which form when two solutions are mixed and an insoluble compound comes out of the solution. So one of those combinations forms an insoluble substance, and of course being insoluble, it will have to come out of the solution. And it does so as a solid substance, which we call a precipitate. There's a range of different combinations of solutions that can produce a range of different precipitates, and one thing that does distinguish quite a lot of the different precipitates is their color. While a large number are white, and we will look at some examples of precipitates, and you'll actually do the experiments as well to start producing some of these precipitates. They're not all white, and sometimes the ions can actually be identified from the color of the precipitate. So let's have a look at a couple of reactions just to kick us off. So the first one is potassium iodide and lead nitrate, forming potassium nitrate and lead iodide. So consider it as we have a cation and an anion for each of these two ionic substances, and all that happens is they're going to swap partners with one another. So these are in solution, and if the bonds that form between the individual ions are so strong that they overcome that attractive force for the ions in water, then they will actually link together and start to form a solid. And whilst this does not happen for potassium nitrate, it does happen in the case of lead iodide. And this forms a beautiful yellow precipitate. So the yellow precipitate will be the lead iodide, and it forms as a consequence of the fact that it is a 2+ ion. Iodine forms a 1- iodide ion. The nitrate also is 1-, and the potassium is 1+. So you can see that all we've done is we've switched over our cation and our anions, and we have new combinations. This is the key to precipitation reactions. All you need to do is look and see if you can identify where the cations and where the anions are, swap them over, and then we're going to use some solubility rules to help us to determine what's actually forming. In the second situation there, can you see what the substance choices are? Well, if I split them down again, I have barium, which is a 2+ ion. It's a metal, so it's a cation. The nitrate, again, nitrates are going to come up quite a lot, and you'll see why in a few moments. It's the anion from barium nitrate. For copper, copper is also something that can have multiple valences, but most commonly 2+, a cation. And the sulfate is a 2-. Now, I should point out at this point that we've got a number of these different types of polyatomic ions or radicals, and these are ones that you just need to know at this stage. There's a little list of them, which I've given you previously, and you really do need to try and remember not only the composition, but also the charge on each of these ions. Having said that, when this reaction occurs, we basically just swap the partners. So this one here with this one here, and this one here with this one here. So let me write it underneath those two combinations. One of them is going to be barium sulfate, and one of them is going to be copper nitrate. Okay, we do it this way because this is a 2+ charge and this is a 2- charge, so electrically they're neutral, so that's fine. This has a 2+ charge, this is a 1- charge, so therefore I need 2 of these in order to balance the 2+, and so therefore the formula is CuNO3 2. Now if you were to see a precipitate from this reaction, and in fact for this particular one you would see a white precipitate. How would we know if the white precipitate is actually barium sulfate or copper nitrate? Well, in order for us to identify that, we need some rules in order to determine which is which. To do that, we have a number of solubility rules, and one of the first and most important rules is that all nitrates are soluble. So in our two choices of copper nitrate and barium sulfate, If the first rule is all nitrates are soluble, this one can't be the precipitate. So it's soluble. And if it's soluble, it won't form a precipitate. Group 1 compounds. Now, group 1 compounds are lithium, sodium, potassium, rubidium, and so on. So these are the extreme left of the periodic table, the group 1 elements. They're all active metals, and when they form compounds, they form soluble compounds in water. So they're all soluble in aqueous solutions, all of them. So is ammonium, and ammonium is NH4+. Okay, so ammonium compounds. And what we're talking here is ammonium nitrate, ammonium chloride, ammonium hydroxide, ammonium sulfate, etc. So all of these different types of compounds that are compounds of ammonia or compounds of sodium, lithium, potassium, are all soluble in water. The next group that are pretty much all soluble are the halides, specifically in this case chlorine, bromine, and iodine. I won't deal with fluorine in this particular video, but the chlorides, the bromides, and the iodides are all soluble with two exceptions. So the exceptions are silver and lead for the halides. So silver chloride, lead iodide, we had in the earlier slide, is an example of an insoluble halide, but most of them are soluble. And as far as the sulfates are concerned, most sulfates are actually soluble, but there are some exceptions, the same two exceptions we had for the halides, silver and lead, but also a couple of group 2 metals. And one of those is barium. So that means from our exceptions, barium sulfate is insoluble, and so therefore barium sulfate now must be positively identified as the precipitate. We said it was a white precipitate, and we can indicate that with the little symbol S to say this is a solid. This has come out of the solution and it is a solid. The rules around solubility also exist for a number of substances that are insoluble. So the carbonates, CO3 2-, are all insoluble. The exceptions are the ones we would expect, the group 1 elements and ammonium compounds. Phosphates, PO4 3-, these are also insoluble, and again the exceptions are the group 1 metals and ammonium. So what we're talking about here is, so for example, sodium 3-phosphate would be soluble. Ammonium carbonate would be soluble. Okay, so that's what the exceptions are telling you here. The last one is the hydroxides, and these are OH-, and the hydroxides again are insoluble with the exception of the group 1 and again group 2 elements, barium, strontium, and calcium, and of course ammonia, which we said before is also always soluble. So these solubility rules are ones that we'll have up and we'll refer to them regularly. We'll carry out some experiments just to test some of these rules and identify some of these precipitates, but we'll deal with that as we go further on. Thanks for watching.